first presentation of the afternoon is by Kristin Beyer. She's going to be presenting using radio telemetry to track seasonal distribution and home range of gopher tortoises on a barrier island in southwest Florida.
Hi, so my name is Kristin Beyer, and I'm a graduate student at Florida Gulf Coast University in Fort Myers, Florida. So gopher tortoises live in dry, sandy areas that have low canopy cover and abundant low-level vegetation. These habitats can be pine flatwoods, oak sandhill, scrub, dry prairie, xeric hammock, mixed hardwood, and coastal dune. These are all managed and maintained by wildfires. The coastal dune ecosystem is unique because it represents a transition zone between the marine and terrestrial habitats. There has been very few studies done and a paucity of information on the coastal dune habitat. Most studies so far have been done in pine flatwoods and scrub habitats in more northern areas. So our study site, which I'll discuss in more detail later, as you can see in these pictures here, is a coastal dune habitat. You can see that the tortoise here is utilizing a secondary dune ecosystem where the vegetation is much different than in other habitats. So it's important to understand how tortoises use their habitat for conservation and management purposes. Tortoises move widely in search of food, breeding opportunities, shelter, and nesting sites. Insights into these movement patterns can help us understand growth and reproduction in gopher tortoises. So home range estimates can help land managers and conservationists conserve habitat sizes that are large enough to conserve target numbers of individuals. And then, okay. All right. So our research goals were to explore habitat use and movement patterns and a population of gopher tortoises in a southern dune ecosystem. First, we want to look at male home range sizes and female home range sizes. We wanted to see if male home range sizes were larger than female home range sizes as seen in other studies. We also wanted to look at the home range size differences between the warmest and coolest months. These months being December, January, and February for the coolest, and the warmest being July, August, and September. In more northern studies, gopher tortoises have been found to hibernate in the winter and utilize smaller percentage of their total home range size in the winter than in the summer. We wanted to see if our tortoises having warmer winters would also utilize a smaller percentage of the home ranges. We're going to look at this using minimum convex polygons to compare the home ranges sizes of the winter and the summer. Okay. Oh, it's not responding. Oh, okay, there it goes. Hold on. Okay. So our study site was Delmar Wiggins Pass State Park. It's in Naples, Florida, in southwest Florida. It's a 166-acre park, primarily composed of maritime hammock, beach dune, mangrove swamp, and submerged land. The east of the road here, you primarily see mangrove and estuary. To the west of the road, there's 24 acres of beach and beach dune habitat, and a mile-long strip that's used by beachgoers for sunbathing, swimming, and fishing, etc. The tortoises range is restricted to the beach dune habitat between the ocean and the parking lot and road to the east. There's also a small area at the very north of the island at Wiggins Pass where there's also gopher tortoises. The habitat the gopher tortoises utilize is very linear and suggests that their habitat is restricted by these structures. Dr. Phil Allman has conducted mark recapture studies in this area of the park, and he estimates the number of individuals to be 100 to 110 individuals. So for our study, We attached Polo Hill transmitters to tortoises in 2014 and in 2016 to male and female tortoises. We used different tortoises both times. We collected data once a week or twice a week, and we recorded their GPS locations. We also recorded their activity at the time, whether they were outside the burrow, at the burrow entrance, on the apron of the burrow, or inside the burrow. So today I will be presenting a portion of our project as indicated by minimum convex polygons that are calculated with minimum bounding geometry and GIS. And specifically, I will be presenting and illustrating the patterns between the seasons and the sexes. So this is the table of this is our raw data. We have the sex, the carapace length, the tracking events, the minimum convex polygons in hectares, the minimum convex polygons for warm, cool, and the percent warm and percent cool of habitat utilized. I'd like to point out a few interesting things about this data. Okay, so first that we have a large variety in tracking events, with the lowest number of tracking events being 34 and the highest being 161. So the large variation means that some of our minimum convex polygons have much higher resolution than others. And I'd also like to point out that for some of the tortoises, we do not have the minimum convex polygon for warm. That is because the radio transmitters that we're using, the batteries died before we were able to collect all the data for the warm months. I'd also like to point out, they say there's one tortoise here, there it is, has a 0 for her MCP cool, minimum convex polygon cool home range. It wasn't actually 0, but when we rounded the numbers, it was very low, so it went down to 0. So the most interesting thing about this data here is that when you look at the female home range, percent cool utilized home ranges, you see that many of the females utilize a lot of their home ranges in the cool months. We have some females as much as 87%, 73%, and 58%. We have one female that had 2.55%, but she definitely seems to be lesser degree. Okay. Yeah, not responding again. Okay. All right, so here I have examples of minimum convex polygons for the population. To the left, we have the male minimum convex polygons, and to the right, we have the female. As you can see, the male convex polygons are quite a bit larger than the females, and in both sides, you can see that the home ranges represent linear shapes and represent the linear beach dune habitat that they're utilizing. After calculating the averages, we have the male average hectares at 0.8 and the female average hectares at 0.28. Okay. So here we have the polygons combined. Again, it shows the linear form of the habitats, and it shows that there's many female habitats often overlaying the male habitats. And this one's pretty interesting. This is the seasonal minimum convex polygons, outlined in blue for the male and red for the females again. The white is a total home range polygon. The yellow is the warmest summer months, and the blue is the coolest winter months. And then the green is the overlap. This map shows again that our tortoises are moving a lot in the winter, as our cool polygons are quite large, just as the warm seasonal ones are. All right, so our male home range, averages found at 0.8 and the females at 0.28. This was found to be actually significant when we ran the ANOVA. The p-value was less than 0.05. Also in this table, it's very interesting to see that the females, they're averaged 51% using their habitats in the wintertime, and only 25% of their habitat was used in the warmest months. The males are much more equal. So, really loud. This video I wanted to include because it's interesting, and a park ranger took this video, and he said that he saw this tortoise that he sees quite a few times swimming in the water here. The tortoise is sitting on the edge of the ocean where the waves gently rolled in, and he swam out pretty far out where you could barely see him anymore. Another 20 minutes, he said, before he came back in, curled back up on the beach, and disappeared into the dam system. He said that he's also seen one of our radio tech females exhibit similar behavior. She went out for a few minutes before returning. This is very interesting because, the literature, there isn't really anything stating that gopher tortoises are commonly found swimming. And it's also an area of investigation that could be, utilized to see why the tortoises are exhibiting this behavior. And it also could be showing that these tortoises are unique and that they're using all parts of their beach habitat. All right. So for the discussion, we found that males have larger home ranges than females, and this could be for reproductive purposes. We also found that, home ranges are within the range of previous studies, but on the lower end. This could be because the quality of the habitat is good enough that they do not have to travel to look for food. And the habitat structure being between the beach and mangroves may limit the size of their home ranges. We found that the tortoises are active year-round, maybe more so even in the cooler months. And the females are utilizing more of their territory, home ranges in the winter than in the summer. So this could be giving them more social opportunities and foraging opportunities, which could be giving them more opportunities for reproduction and growth. All right, so in conclusion, I'd like to thank all the herpetology students who have helped out through the process of this project. There have been countless people who have helped. And I'd also like to thank the Florida Park Service for allowing us to conduct the study, and the Whitaker Center for their funding for the radio transmitters.